Hi everyone, welcome back to our channel. Today we're going to talk about AI-powered robots, the future of manufacturing. The manufacturing industry is undergoing a radical transformation driven by the rapid advancement of artificial intelligence and robotics. AI-powered robots are no longer confined to science fiction. They are a critical part of modern factories, reshaping production processes, working dynamics, and global supply chains. Unlike traditional automation, which relies on pre-programmed instructions, these intelligent machines can learn from data, adapt to new situations, and make decisions in real time. This shift is not just about efficiency, it is about redefining what's possible in manufacturing. Predictive maintenance, reducing downtime and costs. One of the most significant advantages of AI-powered robots is the ability to predict and prevent equipment failures before they occur. Traditional manufacturing often relies on reactive maintenance, fixing machines only after they break down and leading to cost unplanned downtime. AI changes this approach entirely. By continuously analyzing data from embedded sensors, these robots can detect subtle changes in vibration, temperature, or performance that indicate potential failures. For example, in automotive manufacturing, AI algorithms monitor robotic welding arms, predicting when a component might wear out and scheduling maintenance during planned breaks. This proactive approach can reduce machine downtime by up to 50%, saving millions in lost production. Companies like Siemens and General Electric already use AI-driven predictive maintenance in their smart factories, cutting maintenance costs by as much as 30%. This results in fewer disruptions, longer equipment lifespans, and smoother production flow. Enhanced quality control with computer vision. Quality control has always been a challenge in manufacturing, especially in high-speed production lines where human inspectors can miss microscopic defects. AI-powered robots equipped with advanced computer vision systems are changing this. These robots use high-resolution cameras and deep learning algorithms to inspect products with superhuman precision, identifying flaws as small as a fraction of a millimeter. In the electronics industry, where even a tiny defect can render a device useless, AI-powered inspection systems can circuit boards at lightning speed, detecting faulty soldering, misaligned components, or micro cracks. Tesla, for instance, uses AI-driven visual inspection in its gigafactories to ensure battery consistency. Similarly, pharmaceutical companies employ AI robots to check pill coatings and packaging integrity, reducing recalls and ensuring compliance with strict regulations. The impact is clear: fewer defective products, less waste, and higher customer satisfaction. Collaborative robots, cobots, working side by side with humans. One of the most exciting developments in manufacturing robotics is the rise of collaborative robots, or cobots. Unlike traditional industrial robots, which operate in safely cages to prevent accidents, cobots are designed to work safely alongside human workers. They are equipped with advanced sensors that detect human presence, allowing them to stop or adjust their movements to avoid collisions. Small and medium-sized manufacturers who previously couldn't afford large-scale automation are now adopting cobots due to their affordability and ease of use. For example, a small auto parts supplier might use a cobot to assist workers in assembling complex components, reducing physical strain and improving precision. Universal Robots, a leading cobot manufacturer, reports that businesses using their systems see productivity increases of up to 30%. These robots are also highly flexible, unlike traditional robots that require weeks of reprogramming for new tasks. Cobots can be quickly reconfigured for different jobs, making them ideal for custom or low-volume production. AI in supply chain optimization. Manufacturers face constant challenges in supply chain management, such as delays, material shortages, and unpredictable demand fluctuations. AI-powered robots help solve these issues by optimizing inventory, predicting demand shifts, and even adjusting production schedules in real time. Some factories now use digital twins, virtual replicas of physical production lines, to simulate different scenarios and identify the most efficient workflows before implementing changes in the real world. For example, a food processing plant might use AI to analyze weather patterns, transportation delays, and consumer buying trends to adjust production schedules dynamically. If a supplier delay is predicted, the system can automatically reroute materials or prioritize different production lines. Companies like Amazon and BMW already use AI-driven logistics robots in their warehouses, ensuring their parts and products move seamlessly through the supply chain. The result is a more resilient, responsive manufacturing system that can adapt to disruptions faster than ever before. Sustainability and energy efficiency. As environmental regulations tighten and consumers demand greener products, AI-powered robots are helping manufacturers reduce waste and energy consumption. Smart robots optimize energy usage by adjusting machine operations based on real-time power demand, reducing idle times, and minimizing excess material usage. In the aerospace industry, where precision machines generate significant waste, AI-driven robots calculate the most efficient cutting paths to minimize scrap metal. Similarly, in textile manufacturing, AI systems analyze fabric patterns to reduce offcuts, saving up to 20% in material costs. All these systems, although they are now labeled as AI, are in fact OR, operations research and optimization applications. Some factories even use AI to monitor emissions and suggest process adjustments to meet sustainability targets. With global pressure to reduce carbon footprints, these AI-driven efficiencies are becoming a competitive advantage for forward-thinking manufacturers. While all these things are nowadays labeled as AI, they have been studied and implemented as operations research and optimization techniques for several decades now. Challenges and the road ahead. Despite these benefits, integrating AI-powered robots into manufacturing isn't without challenges. Manufacturers still rely on legacy systems that are incompatible with modern AI systems, requiring costly upgrades. Cybersecurity is another major concern. Hackers targeting AI-driven factories could disrupt entire supply chains. Companies must invest in secure, scalable infrastructure and train workers to operate alongside these advanced systems. Governments and industries are responding with initiatives like Germany Industry 4.0 and China's Made in China 2025, which promote AI adoption in manufacturing. Meanwhile, workforce reskilling programs are helping employees transition from manual labor to roles in robot supervision, programming, and maintenance. It needs to be said that it should be the responsibility of AI providers to make sure that they work with current workers and processes. We should not expect that workers need to adjust to AI, and AI, if it is smart, as people say, should exactly do the opposite. In other words, AI should adapt to workers and not the other way around. Conclusion. The AI-driven factory of the future. The future of manufacturing is undeniably powered by technologies, and AI is one of them. By 2030, experts predict that most factories will rely, at least in some way, on robots and intelligent systems from design and production to logistics and maintenance. AI companies should create systems that help people to improve operations, instead of requiring a complete change of the manufacturing systems. The question is no longer if AI-powered robots are possible. It's, however, how industry is going to create robots that make sense and that help in the manufacturing process. That's what I had for today. Thank you for joining. If you like this kind of topics, subscribe to our channel, and I'll see you in the next video. Thank you.